White from America's favorite game show, Wheel of Fortune, where people get to solve puzzles for big prizes. Look at this. Another problem solved. Speaking of solutions, stay tuned as the Treehouse detectives use math, science, technology, and a few vowels and consonants to solve their latest mystery in the next exciting episode of the NASA SCI Files, the case of the Ocean Odyssey.
Don't forget to look for the answers to the following questions. What is a tide? How are oceans formed? When you see this icon, the answer is near.
Are you sure we're in the right place?
I think so. Kaylee told us to meet her at these coordinates.
This is a nice spot. Peaceful, remote, almost idyllic. Perfect for a picnic. Except for that group of people over there. Of course, your GPS might have been wrong. That's why I brought this compass. Let's see, judging by the sun's position...
Hey, Jacob, that's Kaylee and her friends over there.
Exactly. We should meet them right over there.
Hey guys, glad you can make it. Why don't you start cleaning up over there?
I thought we were supposed to be having a picnic.
Yeah, all that paddling made me hungry.
Sorry guys, we have to clean up first, then we can eat.
Then we'll just have to clean up again.
Yeah, but the team that takes up the most trash gets lunch and dessert.
I knew there had to be a catch.
This is interesting. Hey, guys! Hey, guys! Come here!
This is really strange. Now let's review the facts. We found 11 pairs of identical shoes on the beach, covered in what we believe to be an oily goo.
You mean oily substance?
Right, an oily substance.
Then we found globs of the oily substance all over the beach.
Sounds like we have ourselves another mystery.
Exactly.
I say we take a few pairs back to the treehouse for further research. Hopefully, we can figure out this mystery and clean up the beach.
And we might even score a cool new pair of shoes in the process. So they're a little waterlogged. They're still stylish, kind of retro.
What are those? We found all these shoes when we were cleaning up the beach. What's all the black stuff on them?
Not sure. But I got my dad to check them out, and he agrees with me. Oily globs of some kind.
This is Ted Toon. We are receiving a lot of calls about shoes on the beach, and they're covered with oily globs. I Am Listening is reporting live from the oceanfront.
Ted, shoes are washing up everywhere here on the beach, but we think we know the source. A ship that just docked in the harbor reports losing a container off the coast of Virginia in a storm a few days ago.
Isn't it unusual to lose a container?
Apparently not. Over 10,000 containers the size of semi-trailers are lost worldwide each year.
Have there been any reports of oil spills?
No, Ted, we have no reports of any spills.
If you have any leads about where the oil might have come from, please contact KSNN.
See, I knew that it was oil.
So if the container fell overboard, how did the shoes get on the beach?
That's easy. I would say if the shoes were lost off the coast, then the tide must have carried them into the beach.
Sounds like a good hypothesis, but we need to check a little more carefully. Remember, it's always important to do research before jumping to conclusions.
Why are you looking at me when you say that?
I just found a tidal chart, and it says that it was high tide when we found the shoes. I'm sure that's what carried them in.
Wait a minute. This is strange. Look at this shoe. I bought this same style 2 years ago. If they just fell off the ship, wouldn't they be the latest style? I think we need to bring up the problem board.
Good thinking. Okay, so what do we know?
We know that there are tennis shoes covered in oil washing up on the beach.
And that a cargo ship lost a container of shoes off the coast just a few days ago.
We also know that the shoes were found when the tide was high.
So what do we need to know?
We know that tides brought the shoes onto the beach. We need to speak to someone about tides. Maybe Dr. D can help us find an expert on tides. Kaylee, can you email him?
Print out our Get Up and Go sheets from the website, too. Visit the NASA SCI Files website for lots of great tools to help you in your own investigations.
Wait a minute, we've got a call coming in from Tony.
Isn't he someplace in Florida?
Hi guys. Guess where I am? I'm staying in Jules Underwater Hotel, the world's only underwater hotel.
What are you talking about?
Right now, I'm 6.4 meters below the surface training for my future financial adventures.
I'll bet it has something to do with sunken treasure.
How did you know?
Underwater, money, it had to be sunken treasure.
My treasure hunt is going to take many days, so I'm training the same way NASA trains its astronauts for long-term space flight.
Wow, that's really cool.
The confinement, separation, and boredom of space travel are similar to being here in this underwater habitat.
I learned at space camp that you might become more irritable and sensitive to certain noises and odors after you've been confined.
They also say I'll have changes in mood, but I doubt that'll affect me. Mind over matter.
Right. Anyways, while you've been gone, we found a lot of tennis shoes on the beach, and they seem to have oil on them. We need to do some more research. Keep checking in, okay? Bye, Tony.
Okay, I'll talk to you soon. Bye.
Look, an email from Dr. D. He wants a couple of us to go meet Dr. Hoffman at Water Country USA in Williamsburg. Dr. Hoffman's an oceanographer doing research at the park. Then he wants us to come see him at the pier on Dock 21DD.
Research at Water Country USA?
I feel like I'm at the ocean.
Except here, the waves are man-made.
Hi, Jacob and Catherine. I'm Dr. Hoffman from Old Dominion University.
Hi. This is a great place to do research.
We've been wondering, what is a tide exactly?
A tide is the regular rise and fall of the surface of the ocean due to the gravitational force of the sun and the moon on our Earth.
We learned that gravity is a force that exists between all objects.
And it makes objects fall to Earth.
That's right. And the bigger the objects and the closer they are to one another, the stronger the gravitational attraction between them.
The sun is much larger than the Earth and the moon, but a lot farther away from the Earth and the moon. So which one causes the tide?
They both do, but the moon plays the bigger role, being about twice as strong as the sun. As the two of them create a gravitational force on the Earth's oceans, it causes the water to move upwards towards the sun and the moon.
And the Earth's gravity holds the water down.
Right, but the tidal forces pull water sideways along the surface of the Earth, and this tug-of-war creates a bulge in the surface of the ocean.
If the moon's influence is stronger than the sun's, then is the bulge bigger beneath the moon?
Yes, and due to the rotational motion of the Earth-Moon-Sun system, there is also a bulge on the opposite side of the Earth away from the sun and the moon. These bulges of water are large waves that we call high tides.
So if the water bulges on opposite sides, then it must draw water away from the area between the bulges.
Very good, and that is where low tides occur.
How often do we have high and low tides?
Many coastal locations, such as the Atlantic and Pacific coast, experience 2 high and 2 low tides each day. But some areas, such as the Gulf of Mexico, only have 1 of each.
Do the tides in a particular place always occur at the same time?
No, but the answer's a little bit complicated. On average, high tides occur every 12 hours and 24 minutes. The Earth spins on its axis every 24 hours, so if you divide 24 by 2, you get 12. The extra 24 minutes is because of the moon's orbit about the Earth.
Would high tides help bring objects floating in the water onto the shore?
Tides do not typically have much of a role in transporting objects in the ocean. You can think of tides as a big sloshing motion where objects go as far in one direction as in the other. Here, let's check it out.
was cool, but what about the waves?
Jacob, can you get in the pool?
Can I?
See the waves around Jacob? They look like they're moving the water forward, but actually they aren't.
How is it that I stay in the same place?
Each particle of water in a wave moves around in a circle. Energy moves forward while water particles remain in the same place, so an object floating on the water will rise and fall as the wave passes, but the object will not move forward.
I think we definitely need more research about waves.
Me too. Thanks, Dr. Hoffman.
You're welcome. Enjoy the wave pool.
You better stop researching the waves if you want to get there on time. Bianca does not like to be late. We're getting close. Isn't it 21 DD? There it is.
DD for Dr. D? He has his own boat dock?
Over here. Welcome to the Maury, Tidewater Community College's research vessel.
Dr. D, we learned about waves and tides, but we need to know more about oceans.
Let's start at the very beginning. You know how oceans formed?
You mean they weren't always here?
No, not always. When the Earth began about 4.6 billion years ago, volcanic eruptions helped to form an atmosphere. That included water vapor.
So were the oceans created when it rained?
That's right. About 3.8 billion years ago, the lower areas of the Earth's crust, called basins, filled with rainwater.
If the ocean is made from rainwater, why is it salty?
Well, in the beginning, it wasn't very salty.
So how did it get that way?
One way is from freshwater rivers. As they flowed towards the oceans, rivers dissolved minerals, such as salt from the land, adding salt to the ocean.
But how can the ocean be more salty than the rivers?
When water evaporates from the oceans, it takes almost pure water away, leaving the salt behind.
Then for millions of years, the rivers carried salt into the oceans, and evaporation leaves it there.
Do the oceans continue to get saltier?
No, and they're not getting any less salty either. We say saltiness or salinity has reached equilibrium.
Why is the salinity of seawater so important?
One reason is that it's a major factor in creating ocean currents. Let's do an experiment. I'm going to pour salty water into fresh water. Let's see what happens.
The salty water went to the bottom. Why is that?
Salty water sinks to the bottom because it's denser than fresh water. A gallon of salt water weighs more than a gallon of fresh water. Jacob, test it out.
They both feel the same.
Salt water from the ocean is only about 3% heavier than fresh water. But even a small difference in density makes a real difference in currents.
Is there anything other than salinity that determines the density of water?
Yes, the temperature does.
I think we're going to have to learn more about how density makes currents.
I have a friend named Dr. Martins who can help you. He's doing research in an underwater laboratory called Aquarius. I'll give you his contact information.
Thanks, Dr. D.
What's up? Did the tennis shoes come from the recently lost container? Where did the oil globs come from? How did the tennis shoes get to the beach? Don't miss the next exciting chapter of the NASA SCI Files.
In this segment of the Case of the Ocean Odyssey, look for the answers to the following questions. How do cold temperatures make water denser? How are surface currents created? How do you find the speed of a moving object?
Good morning, Kaylee. You're off to an early start.
I sure am. I was doing some research, trying to figure out how those shoes washed onto our beach. But I'm not sure what we need to know next.
We have a lot of information about tides, and Dr. D told us how oceans formed.
Speaking of oceans, I wonder how Tony's doing in his underwater habitat.
Let's call him.
Hi everyone. Today I started my day with a swim around the hotel exploring underwater. Then I came in for something to eat and I watched a video. This is a piece of cake. I'm not showing a single sign of irritation.
That's great, Tony. Dr. D told us about an underwater research lab called Aquarius.
I've been to their website. It's a really cool lab.
It'd be great to talk to some of the scientists that live and work.
I don't mean to be rude, but I need to go. Talk to you later.
See you later, Tony. That was strange. What are you doing?
I'm taking notes for my IOI report.
IOI report? What's that?
Incidents of irritation. Tony's definitely showing symptoms of isolation.
Well, it's difficult to tell with Tony. He could have had a bad day with the stock market. I have the contact in here somewhere for the Aquarius expert. Here it is. Can you dial them up?
Sure.
Hi, I'm Dr. Martins. Glad you found me.
Hi, Dr. Martins. Dr. D told us that the density of water depends upon its temperature and salinity. But how does temperature make the water more dense?
Cold water molecules are packed together more tightly than warm ones, making cold water denser.
So do the density currents form near the north and south poles?
Exactly. The cold air at the poles cools the surface water, making it denser and causing it to sink.
What about salinity?
When ice forms in polar waters, it leaves behind salt, which increases the salinity of surrounding water.
The higher salt content makes the polar water denser.
I learned that evaporation also makes water saltier.
That's right. In areas such as the Mediterranean Sea, where there's little rainfall and lots of heat, evaporation removes fresh water and leaves extremely salty water.
Where does the denser water go?
The denser polar water sinks and creates the thermohaline circulation.
Thermohaline?
Yes, thermo for temperature and haline for salinity. The cold salty water masses that create this circulation form in only two places. The water mass sinking off Greenland is called the North Atlantic Deepwater, or NADW. The water mass sinking off Antarctica is called the Antarctic Bottom Water, or AABW.
Where do these currents end up?
They both sink down several kilometers while spreading out horizontally and moving along the bottom of the Atlantic Ocean. They eventually mix while circulating around Antarctica. Then they move into the deep Indian Ocean and finally into the Pacific.
So the water from the poles may one day end up on a beach in Hawaii?
I guess you can look at it like that. What goes down must come up. It takes the average water molecule 1,000 years to make the complete cycle.
Wow, that's a long time.
Yes, we call the cycle the global conveyor belt, and it has a large impact on climate.
I went swimming once, and the water was really cold. My mom said it was an upwelling, but what's that?
The coastal upwelling that you experienced is different from thermohaline circulation. It only brings up cold water from a few hundred meters deep.
It's also not as cold as AABW or NADW. Coastal upwelling is generally caused by wind.
Is upwelling important?
Good question. Upwelling brings lots of nutrients up from deep water. We are researching the impact of nitrogen, a crucial nutrient, on Florida Keys reefs.
How does upwelling affect the reef?
It appears that there have been major changes in the health and community structure of coral reefs here in the Keys and throughout the world. By observing the nitrogen composition of sponges, we can determine the importance of different nitrogen sources.
Wow, you've given us a lot to think about. Thanks, Dr. Martin.
You're welcome. Good luck on your project.
That was very interesting. Density currents might be the key to solving this mystery.
Remember the longshore currents we learned about in the case of the disappearing dirt? They move large amounts of sand from one place to another. If they can move sand, they can surely move shoes.
That sounds like our new hypothesis. If the container fell overboard and was caught in an upwelling, then the longshore currents brought the tennis shoes to the beach.
That's true, and the container was lost not far from the beach.
Hello! Dr. Textbook here. Did you know that the Gulf Stream once helped to solve a postal problem? Well, it seems that during colonial times, the colonists constantly complained of their snail mail taking 2 weeks longer coming from England than going to England. Well, the postal authorities in England contacted the Deputy Postmaster General, Benjamin Franklin, a man who I can greatly relate to. It seems that wily old Ben had a cousin who was a seafaring captain. His name was Timothy Folger, and Tim told cousin Ben about a strong surface current that comes from Florida up the east coast of America. When ships sailed to England, they went north and sailed in the stream. The swift current helped them sail faster and deliver the mail quicker. But ships sailing from England headed south, sailing against the stream, which slowed them down. Now, Mr. Franklin decided to draw a more detailed map of the current and named it the Gulf Stream because it flowed out of the Gulf of Mexico. When settlers from here at Jamestown Settlement in 1607 would send mail to England, they would use ships much like this replica of the Susan Constant. Many of you have heard the saying, sending a message in a bottle. Well, I'm going to send my own message in a bottle to my aunt who lives in England. I have this $100 bill. I'm going to write her name on the front of it, and I'm going to place it into the bottle. If the wind currents and the ocean speeds are correct, she can expect her own Ben Franklin to arrive in time to buy me a gift for my birthday. Here we go! Not a very good idea.
Dr. Textbook just mentioned surface currents. I think that's our next investigation.
We need to open the problem board.
Good idea. We need to update and be current with our information. Okay, we know that old shoes and oil globs have washed up on the beaches around our area.
We know that tides don't carry items long distances.
And we know that density currents are cycles that cause global circulations of the ocean's water.
So what do we need to know?
Well, the lost cargo fell overboard, only a short distance from Virginia.
And if the tides didn't carry the shoes to the beach, then maybe it was some other type of surface current, like a longshore current. I think we need to know more about surface currents.
And we also need to know more about oil.
Did I hear you say something about oil?
How did you just pop in?
Someone must have dialed me up. I agree, we need to learn more about black gold. Oil. And how you find it and get it out of the ground.
I see that your mind is still focused on money. How's it going down there in your habitat?
It's great down here, really. There's a lot of cool things to look at underwater. It's so different from land. I think we need to... Did you hear that noise? I've got to go check it out. See you later.
Poor Tony. I think he's suffering from another IOI. My mom has a meeting with Dr. David Adamak at NASA Goddard Space Flight Center. He researches currents. She said I can go with her to meet him.
Sounds like a plan. And Jacob Stanley's taking a vacation to Houston, Texas. I'll ask him to do some research in oil country. And don't forget to take a Get Up and Go worksheet from the NASA SCI Files website with you.
Hi, Bianca. Thanks for meeting me here. I had a taping earlier today.
That's cool. I've had a little bit of experience in front of cameras. Dr. Adamek, we learned about density currents, but we need to learn more about surface currents. So what exactly is a surface current?
A surface current is water moving near the ocean's surface, above what we call the thermocline.
Thermocline. I know that therm has something to do with temperature.
Right, and cline means change, so a thermocline is a region of temperature change.
Where is the thermocline?
Typically between 50 and 150 meters deep.
So how do surface currents form?
Friction between the wind and the surface water causes that water to move.
We learned in the case of the mysterious red light about global wind patterns, and that winds blow in a certain direction depending upon where they're located on Earth.
Right. For example, the trade winds push the surface currents around in the tropics.
But are there other factors?
Oh, sure. Because the Earth rotates, there's turning due to the Coriolis effect.
Isn't that when the wind is deflected to the right in the northern hemisphere and the left in the southern hemisphere?
Yes. And another factor that steers currents is the topography, the hills and valleys on the ocean floor.
How does the topography underwater affect the surface currents?
I'll show you. Sit on the stool. Now don't try this without an adult, but I want you to stick your arms and legs out. And once I spin you, I want you to bring your arms and legs in close to your body, okay? You ready? What happened?
I spun slower when my arms and legs were out, and faster when they were in.
Topography does the same thing to currents. If a current flows over an underwater mountain, the water column gets flattened and compresses. That's you with your legs out. The water spins differently, and the currents get deflected.
Why are some surface currents cold and some others warm?
It depends on where the water's coming from. If it's coming from the poles, it's cold. If it's from the tropics, it's warm.
Do warm and cold currents affect the climate of an area?
It's a good question, Bianca. Yes, they do. For example, Ireland is pretty far north, and you might expect it to be cold there. But the Gulf Stream flows past Ireland, and the warm water heats the air, which helps to create a surprisingly mild climate. They even have palm trees in Ireland.
Really? With currents located in every ocean, I guess they could be responsible for bringing the tennis shoes and oil to our beach.
It's possible, but you got to be careful. The same current can transport things to different places.
How does that happen?
You dropped the balls at the same time and all in about the same place. They ended up in different places. Why?
Is it because there are so many different variables, such as the pits in the pavement, or even the shape of the ball?
Exactly. The same thing happens in the ocean. Tiny variations in the current can lead to large differences where the current might actually move things like your tennis shoes.
Wow, that's amazing. I'm curious, why does NASA study currents?
Earth's oceans have the greatest influence on climate, and only from space can we monitor the vast oceans on a global scale and monitor critical changes in the currents and the heat storage.
Why is that so important?
Well, the oceans cover 70% of the Earth, and the currents in the ocean are an important part of the water cycle. Any change in the water cycle can cause major consequences on our Earth.
How does NASA monitor the ocean?
We use different satellites to monitor things like currents, waves, temperature, and pretty soon even salinity.
That's really interesting. I'm always amazed at all the research NASA does to help protect our Earth. Thanks, Dr. Adamek. This information has been very helpful.
You're welcome. And call if you have any more questions.
Are you ready for some research?
I love doing research with Dr. D.
Did you bring the items I requested?
Of course. I brought some old tennis shoes and Catherine brought some soccer cones.
Great. I wanted to meet you here at the Hubba Hubba Highway because the speed of its current is a lot like the Gulf Stream.
It looks like it's moving pretty fast. Does the Gulf Stream move that fast?
Let's find out. I brought a stopwatch and a measuring tape so we can find its velocity or speed.
I know the formula for velocity. It's distance divided by time. So if we measure the distance between 2 points and then time a floating object between them, then we can find the velocity.
Very good.
We need to do 5 trials. You should always do more than 1 trial in an experiment and then find the average.
Excellent. Next, we need to decide how far apart the 2 points should be and mark the distance with the cones.
How about putting them 10 meters apart?
Fine. What object should we time?
Oh, I get it. That's why we brought these tennis shoes.
That's correct. Let's get started.
Averaged 8.65 seconds. So if we use the formula and divide 10 by 8.65, that means that the velocity is about 1.2 meters per second.
The Gulf Stream's velocity averages between about 1 and 1.5 meters per second.
Wow. Both the Hubba Hubba Highway and the Gulf Stream move really fast.
Now it's time for you to experience the power of the Gulf Stream by swimming against the current.
It should be easy.
Let's see which one of you is a stronger swimmer.
I predict no contest.
That's right. I'll be the champ. Wow. That was a lot harder than I expected.
I can certainly see why it took 2 weeks longer to get mail in colonial days when the ships were sailing against the current.
Okay, there's still more research to do. Let's float around the Hubba Hubba Highway and see if we all float at the same speed.
This sounds like my kind of research.
So what's up? Did a surface or density current bring the tennis shoes onto the beach? Why is the velocity of a current important to solving this case? Will the treehouse detectives discover oil? Don't go away. Stay tuned to learn what happens next in the case of the Ocean Odyssey.
Answer the following questions. What condition must exist for oil and gas to form? In North America, where does most oil pollution come from? What does the ocean floor look like?
Mr. Bernhard works here at the Houston Museum of Natural Science. I asked him if he could tell me more about oil and especially where to find it.
Welcome to the Houston Museum of Natural Science. You've come to the right place if you want to learn about oil.
I learned in school that oil, gas, and coal are called fossil fuels because they're made from plants and animals that lived millions of years ago.
That's correct, but we actually have to start further back than that when the Earth was first forming.
Really?
Billions of years ago, the Earth's crust began to move around on top of the Earth's hot liquid center. This movement created spaces between the land known as sedimentary basins. Let me show you.
That's what I call research.
Just imagine that the chocolate is the land and the chewy caramel is the Earth's liquid center. You see the sunken spaces opening? These basins made the perfect places for oil and gas to form.
Cool. So what happened after the basins formed?
These basins fill with water, forming oceans, seas, and large lakes. Billions of microscopic plants and animals thrived in these basins.
How did the plants and animals become oil?
The plants and animals died and their remains piled up on the basin floor. This organic matter eventually transformed into oil and gas.
Wouldn't the dead plants and animals just decay and decompose?
Under normal conditions, yes, but for oil and gas to form, anaerobic conditions must exist.
What are anaerobic conditions?
Those are just places where there's no oxygen present. The organic material was then covered by sediment, forming distinct layers of sedimentary rock. Have a look at this.
That's cool. So once the organic matter is covered with sediment, how does it become oil?
The weight of the layers of mud and sand combined with heat from inside the earth turn the mud and sand into layers of rock.
We learned that the deeper you go into the earth, the hotter it gets.
That's right. And as the organic source rock was buried deeper and deeper, temperatures reached 100 to 150 degrees Celsius, cooking the organic matter into a gooey black soup that became black gold, or Texas tea.
Tony would like to hear about black gold.
The rock above the oil may look solid, but it actually is very porous and contains millions of tiny holes. You see this flask of oil and water? Can you tell which layer's on top?
It's definitely the oil.
You're correct. Oil is lighter than water, so it keeps floating up through the spaces in the rock above it. It will eventually either reach the surface or be trapped by an impermeable layer of rock.
You mean rock without holes?
Yes. This layer traps the oil and it begins to build a reservoir.
This information is really helpful. Now I just need to find out how you get the oil out of the ground.
We've got some great exhibits here to help you learn how oil is extracted. Feel free to look around.
Thanks, Mr. Bernhard.
You might also want to talk to Mr. Wells. He's at the Ocean Star Museum in Galveston. He used to be a working oil rig.
That would be great.
Hi, Jacob. How can I help you?
Can you research any recent oil spills from oil rigs?
Of course I can. We're here doing research right now.
For some great tools to help you evaluate the content of websites, visit the NASA SCI Files website. Hi, Mr. Wells. I'm Jacob.
Hello, Jacob.
Can you tell me more about offshore oil exploration and production?
Sure. This is the perfect spot. We are standing on the drill floor of the Ocean Star.
Wow. This looks very interesting. What's the tower for?
It's called a derrick. It has a pulley system for raising and lowering lengths of casing and drill pipe.
Casings?
Yes. Casing is steel pipe that forms the wall of the wellbore to ensure the stability of the well we've drilled.
What happens next?
Next, a drill bit is attached to the drill pipe, and the whole assembly rotates like a hand drill to cut the hole.
I read about drill bits. They can cut through rock.
That's right. Actually, they're specifically designed to just do that. As we rotate the drill pipe and the drill bit, it cuts up the rock, and we pump mud down the drill pipe to help bring the cuttings back to surface.
Mud? You mean like water and dirt?
Well, not exactly. This is a specialized drilling fluid we use to help cool the bit and bring the cuttings back to the surface.
Do you always find oil when you drill?
Unfortunately, not always. But through new technology, NASA satellite imaging, and seismic techniques, we've actually greatly increased our chances of finding oil.
Once you find oil, how do you get it out of the ground?
After removing the drill pipe and bit, production tubing is put into the wellbore. Then a perforating gun is used to make holes through the cement and casings so the oil can flow into the well.
We're looking for a source of oil pollution in the ocean. Are there offshore oil rigs on the east coast of the United States?
Actually, there aren't any. Most of them are in the Gulf of Mexico. Did you know, on a worldwide basis, less than 3% of the oil pollution comes from offshore exploration and production operations? In fact, the ones that I've been involved in, it's little, if any.
Wow, that's not very much. Where does most of the oil pollution come from?
Actually, in North American waters, greater than 60% comes from natural seepage.
You mean it just bubbles up from the floor of the ocean?
That's right. Once the oil moves up through the earth to the ocean floor, it just rises to the surface.
Because oil is less dense than water.
Very good. And the Gulf of Mexico is one of the largest natural sources of oil seepage in North America.
It sounds like we need to learn more about oil seepage.
That's a good idea. A marine geologist can help you learn more about the geology and topography of the ocean floor.
Thanks, Mr. Wells.
You're welcome. While you're here, let me show you more of the drilling rigs.
Hi, Jacob. Welcome back.
Did you find out if there have been any reported oil spills from oil rigs?
I have, and there hasn't been a single report of an oil spill or oil rig accident.
That's good. Mr. Wells had mentioned that oil sometimes just naturally seeps from the ocean floor.
Maybe that's a lead. I also did some research on the tennis shoes with the calculations from Water Country.
What did you find?
Even if the surface current traveled as fast as the Gulf Stream, the shoes from the container couldn't get here as quickly as they did.
Guess it wasn't surface currents. This investigation is getting interesting. I think we need to go to the problem board.
Okay, we know that tennis shoes and what we believe to be oil globs washed up on the beach.
We know that currents travel long distances around the world and could have brought the shoes in from far away.
And oil reserves formed millions of years ago in sedimentary basins. And that some oil seeps out naturally.
We also know now that there are no reported oil spills from offshore rigs or oil tankers.
I think we need to verify what was in the container that fell overboard last week. You know, I am as good at jumping to conclusions.
We also need to know if natural seepage caused our oil globs.
We had better not tell Tony, or he'll be looking for oil in his spare time.
I'm serious. I think that needs to be our new hypothesis for the oil globs. If oil is seeping naturally from somewhere along the East Coast, then it will wash up on our beach.
I wouldn't be too quick to make this seeping possibility our hypothesis. Remember in your report, Mr. Wells said that the Gulf of Mexico is the largest natural seepage area.
But Jacob could be onto something. Maybe we need to learn more about seeping oils and the topography of the ocean floor.
Mr. Wells did suggest that we talk to a marine geologist.
We need to find a marine geologist to help us out.
I remember Mr. McNitch. He told us about hot spots on the ocean floor in the case of the disappearing dirt. I think he might be just the person to talk to.
Good idea. He's from the Virginia Institute of Marine Science, or VIMS for short. We need to see if Kaylee can meet up with him.
Oh, by the way, Jacob, Tony told us that the lack of noise is starting to get to him. But I'll ask him about natural oil seepage.
Kaylee said she would be able to meet with him, but Dr. McNitch referred us to Miss Jennifer Mazelis.
I'm here at VIMS with Miss Mazelis. She's showing me the vessels they use to map and take core samples. We learned that there are mountains and valleys on the ocean floor, and that there's natural oil seepage. We need to know more about the topography of the ocean. Can you tell me exactly what the floor looks like?
It's magnificent. Under the ocean, you can find the tallest mountains, the deepest valleys, and the flattest plains on Earth.
Sounds fascinating, but I don't see any mountains or valleys when I swim.
That's because where you swim is actually the continental shelf. This area is located along the edge of the continent and can extend 10 to 200 kilometers offshore.
So are mountains the next area?
No, next comes the continental slope. It starts at the edge of the shelf and dips steeply until you reach the abyssal plain, which is one of the flattest areas on Earth.
And the next area is where the tallest mountains are, right?
Right. In the middle of the ocean, there are mountain ridges called mid-ocean ridges. This is where the seafloor is spreading apart, making new seafloor and building mountains.
I learned about the seafloor spreading apart in the case of the shaky quake when we learned about plate tectonics.
Very good. You'll also find volcanoes over those ridges and over hot spots in the Earth's crust. If a volcano grows tall enough to rise above sea level, they form islands.
Just like the Hawaiian Islands. Didn't they form over a hot spot?
That's right. And if a volcano doesn't break the surface of the water, then it's called a seamount. There are also deep ocean trenches.
I always thought of the ocean as sandy.
Under the ocean is a whole world just waiting to be discovered. And that's where the core samples come in.
Why do you take core samples of the ocean floor?
Seismic reflection images show buried ancient river channels located near here during the last ice age. Coring helps us to verify that they exist.
It seems like we have another mystery, and we need your help.
Sure thing. What can I do?
Right now, we're trying to find out where the oil globs on our beach came from. Mr. Wells said that oil sometimes seeps out naturally from the ocean, so we need to learn more about oil seeps.
Oil and gas can seep directly onto the surface of the Earth, or into the ocean.
Are seeps very common?
Yes, they're quite common. Did you know in California, every oil and gas field discovered between 1860 and the early 1900s was actually found by people seeing it seep up from the Earth?
So how does oil and gas seep out?
Seeps can come from a single point or from as many as 30,000 individual little holes. Divers describe high seepage areas as looking like a whole bunch of gopher holes.
How much oil and gas seeps out?
It varies from place to place and can range from nearly impossible to detect to thick oil films with globular deposits called tar balls.
That sounds like what's on our beach. We learned that most of the oil seepage occurs along the Gulf of Mexico, so we thought that a current could be carrying the oil globs to our beach. But we learned that there aren't any currents that carry things to Virginia from the Gulf of Mexico.
What about the Gulf Stream?
We know that the Gulf Stream flows northward from the central part of the Atlantic Ocean and turns back towards Europe up around Canada. So I don't think that's the answer.
You might want to learn more about the Gulf Stream.
You're right. Maybe it is the Gulf Stream. Thanks, Ms. Masalis.
You're welcome. It's my pleasure to help out the Treehouse Detectives. Let me show you something else.
Tony, welcome to the Underwater Research Lab.
Neat place, Dr. D. Thanks for inviting me.
I understand that you have some exploration in mind.
Oh, I certainly do. I was amazed to find out how much scuba divers can accomplish when they stay in an underwater habitat like the Aquarius.
Scuba divers generally have a maximum depth of 40 meters, and with special equipment, maybe up to 600 meters.
Why can't they go deeper?
Well, the real problem is pressure. The deeper you go in the ocean, the greater the pressure.
Why is pressure a problem?
Well, look at this bottle.
How did you crush the bottle, Dr. D?
I didn't. The pressure crushed the bottle as I brought it down to the lab from the surface. Every 10 meters out in the ocean, the pressure increases by 1 atmosphere.
So what if my treasure is, say, theoretically, deeper than 600 meters?
You can use a submersible or mini submarine. They have thick reinforced walls instead of increased air pressure. Can go as deep as 6,500 meters.
So you're saying if I brought a glass bottle down to the Aquarius, it wouldn't collapse because it's stronger than the plastic bottle?
Very good. Another type of submersible is an ROV, or remotely operated vehicle. In fact, I have one right here.
You're kidding.
Well, mine is a lot smaller than a research vessel, and it uses radio control instead of a cable.
Maybe I could use an ROV to help with my treasure hunt.
Good idea. Besides locating large treasure ships, we can also use these vehicles to inspect oil rigs and pipelines, and to investigate ocean ridges and geothermal vents.
What are these?
These are my 2 other submersibles called RBUVs.
Let me guess. Rubber band underwater vehicles.
You're really on the ball. Let's go outside and have an RBUV race.
So what's up? Will the Treehouse Detectives figure out how to clean up the oil? Where did those tennis shoes really come from? Join us for the final chapter of The Case of the Ocean Odyssey.
In the finale of The Case of the Ocean Odyssey, you need to look for the answers to the following questions. What are absorbents? How is an oil spill cleaned up? What is dispersion?
Are you still examining those shoes?
I believe now that these shoes have traveled a long way.
Why do you think that?
I was just reading about a cargo ship that lost a container near Japan years ago.
Yes, I remember that. And about 10 years later, the shoes washed up on the shoreline of Seattle, Washington.
I am listening here, bringing you this report live from Virginia Beach. Recently, I reported that a container of shoes fell overboard near the coastline. I would now like to retract that report because we have new information which reveals that the container actually held rubber ducks. I apologize for the misinformation and for jumping to conclusions.
I thought my calculations were correct. I knew those shoes couldn't have come from that container.
They got to the beach too quickly, right? So what do we do now?
Problem board, Jacob. Okay, we know that the shoes can travel a very long distance.
We know that currents can move objects long distances, so they probably got to the Virginia coast through the Gulf Stream.
And we still need to know how the shoes got from the Gulf Stream to the beach, and where they originally came from. We now know that oil seeps out naturally.
Right now, that seems to be the only answer to the oil glob mystery.
Even though the oil seeped out naturally, it still made a mess of the beach. I think we need to learn how the oil can be cleaned up. The NASA SCI Files Kids Club website has a posting about cleaning up oil spills. It's with the Key Largo School in Key Largo, Florida. They're working with mentors from the Society of Women Engineers. Teachers, to learn more about getting a classroom mentor, visit the NASA SCI Files website.
Let's dial them up.
Hi, I'm Robert. I'm Jacqueline, and this is Devin. We're in Mrs. Dunn's 4th grade class.
Hi, we saw on the NASA SCI Files Kids Club website that you're working on an experiment to clean up an oil spill. What kind of oil did you spill?
It's not a real oil spill, but a simulated one. We used vegetable oil and cocoa powder and mixed it together to make an environmentally friendly oil.
That's a good idea. Crude oils such as motor oil can be damaging to the environment, even on a small scale.
Exactly. Next, we made our own mini ocean by pouring 5 milliliters of salt into a shallow aluminum pan full of water. Then, we slowly poured our oil on top of the water in the pan.
What happened?
Because oil is lighter than water, it spreads out and floats on top. It looks kind of pretty with rainbow colors, but it isn't so pretty when we try to clean it up.
What do you use to clean it up?
We are trying a variety of things, such as absorbents, skimmers, and detergents.
What are absorbents?
Absorbents are materials such as straw, sawdust, and peat moss, used to absorb the oil off the top of the water.
So did the absorbents help clean up the oil?
Not very well. We still have a lot of oil left and it's very messy. Next, we are trying spoons to simulate skimmers, which are bowl-shaped devices used to skim the oil off the top of the water.
Does that work better than the absorbents?
No, and we didn't get much oil either. Last, we are trying detergent. That works much better. The oil immediately moves and forms globs, but a lot of detergent wouldn't be good for the environment.
That would turn into one big bubble bath. So what did you conclude with your experiment?
We concluded that there is no easy way to clean up an oil spill, but the best thing is to prevent them from ever happening.
I agree. Thanks for sharing your experiment with us.
You're welcome.
Goodbye from Mrs. Dunn's class at Key Largo School in Key Largo, Florida.
Wow, cleaning up oil is complicated and not so easy. It seems like it would take years to get the job done.
I spilled oil on my mom's kitchen floor, and it took forever just to clean a small amount up.
I know that oil spills are not good for the environment, especially for all the plants and wildlife in the ocean and along the coastline. We need to learn more about cleaning up oil spills and what the impact to our environment might be. I'll email Kaylee and ask her if she can help us find someone to talk to.
I've been looking at Kaylee's IOI report, and I wonder how Tony's doing living in the underwater habitat. Can you dial him up? Hi, Tony. How's it going? Have you guys been watching me the whole time? Tony, Kaylee's been keeping an IOI report on you, and you know what? We think it's time for you to come up to dry land. I hate to admit it, but I think you're right. I guess the treasure hunt will have to wait. Thanks. I'll see you soon.
Hurry back. I'm proud of Tony. I know that was hard to do.
There's breaking news in the oil glob mystery. I Am Listening is reporting from Florida.
Ted, we now have reports that oil globs and tar balls have washed up all along the east coast. It looks like it's all coming from here in the Gulf of Mexico.
That's a pretty big place. How did they find the location of the seepage?
Satellites did the trick.
What? Did you say something about lights?
No, Ted. NASA satellites revealed the presence of this seepage.
Oh, yes, of course. NASA is always on the job.
Okay, it appears that the oil is coming from the Gulf of Mexico, but we still need to find out how it got to Virginia. Remember, Miss Marcellus told Kaylee to do some more research on the Gulf Stream. Didn't Dr. Textbook say something about the Gulf Stream being named after the Gulf of Mexico? You're right, Bianca. We need to do some more research.
And what about those shoes? I guess NASA satellites can't see shoes from space.
Wait a minute. Kaylee found an environmental engineer at NASA Wallops Flight Facility who can tell us the impact of an oil spill. And she says RJ is there to meet with her now.
That's great, but we still need to solve the mystery of where the tennis shoes and oil globs came from.
We're getting closer. Let's not get discouraged. Dr. D also emailed and said that Dr. Moisen at NASA Wallops Flight Facility could help us learn more about coastal currents.
Let's ask RJ to talk to him too, and be sure to have him ask about the Gulf Stream.
Ms. Fields is an environmental engineer here at NASA Wallops Flight Facility on the eastern shore of Virginia. She has agreed to meet with me.
Hi, RJ. I read Kaylee's email and I checked out your research on the internet. I understand that you want to learn more about the impact of oil spills and how to clean them up.
Yes, we have lots of oil globs on the beach, and we're all worried about the plants and animals.
Well, you have good reason to worry. The toxic properties of oil can damage or destroy plants and animals. I mean, just a dime-sized blotch of oil on a bird can impair its insulating ability, resulting in hypothermia and death.
That's really serious. How do you clean up oil spills?
Well, the typical cleanup method for ocean spills is to contain the oil with floating booms and then pump it back into recovery tanks. Now, sometimes we do apply chemicals to help disperse the oil slick.
Oil has made a mess of our beach.
I can only imagine. And people don't want to go to a beach that's full of oil globs. Watch how a little oil spreads out, creating a slick on the water.
Wow, it really spread out.
Yes, and a small amount of oil can cause a lot of damage. Look at how the oil clings to the feather. The oil coats the surface of plants and animals, effectively smothering them.
Our area depends on tourism, so I'm sure that the oil on the beach is hurting businesses. Who's responsible for cleaning up the oil from a spill?
Well, whoever spilled the oil is responsible for getting it cleaned up.
Who makes sure they clean up all the oil?
Well, in the United States, it's the Environmental Protection Agency or the Coast Guard.
We learned about cleaning up oil spills from our SCI Files Kids Club. But aren't there other ways that can be done?
Well, during an oil spill, it's critical to try to clean it up before it reaches land and affects the shoreline. So we need to be able to predict where it's headed. The paper dots simulate our oil slick. The slick moves with the water current, and then it's reversed by the wind and wave action. The waves also act to break up and disperse the slick.
So how do you predict where it's headed?
Well, we use planes to fly over the oil slick and we map its location. Then we use current weather and ocean forecasts to create a computer model to predict where it is headed to next. We also use satellites to track which way the oil spill is going to go.
If the oil is at sea, why don't you just let nature take its course and clean it up?
Well, waves will gradually disperse the oil, but it can take a long time depending on the amount spilled. If we act quickly to recover the oil, we can protect the environment.
How long does it take the environment to recover from an oil spill?
It can take years for natural environments to fully recover. That's why it's so important for people to realize that oil spilled in large accidents is not the only way to contaminate the ocean.
What do you mean?
Well, the everyday buildup of small spills and debris can have a significant impact. Stormwater flows over parking lots and streets, and it carries the oil into rivers and streams when it ends up eventually in the ocean.
I never thought of that. I guess that's why it's so important to recycle after you change the motor oil in your car.
Yes, and it's also helpful if there's a buffer zone of vegetation that can trap some of the pollutants.
Looks like we have our work cut out for us. The oil that's on the beach is from natural seepage, so I guess each city will have to clean its own beach.
I'm sure they'll be looking for some good volunteers.
Yes, and I know of 6 volunteers who can help in the beach cleanup. Thanks, Miss Fields.
You're welcome.
Do you know where I can find Dr. Moisen?
I sure do. Come on.
Hi, RJ. I'm glad you found me. Dr. D said you'd be coming by.
Hi, Dr. Moisen. We're trying to figure out the final pieces to our mystery. Well, we had some tennis shoes washed up on the beach, and we don't know where they came from.
Well, that sounds like a real mystery.
It really is. We think that the shoes came from someplace far away, that the ocean currents brought them to Virginia.
That's very possible.
We know that the Gulf Stream flows along the coast of Virginia. We're not sure how the shoes got from the Gulf Stream onto the shore. Dr. D suggests that we come learn more about coastal currents. Are coastal currents different?
Yes, they are. Coastal currents can be located on the surface or on the bottom of the ocean, and they can be formed by density differences or tidal processes, but they are always found near the shoreline.
Well, it doesn't sound like they are the answer.
They could be, but first let's talk about dispersion.
What's dispersion?
Suppose you placed 100 yellow ducks in the center of a pool, turned off the pumps, and went away for 24 hours. Where do you suppose the ducks would be when you came back?
Probably in the center of the pool, because there aren't any currents to move them around.
Actually, you would find them randomly distributed or dispersed throughout the pool.
Why wouldn't the ducks all be in the same place?
Small-scale circulation patterns in the pool that move the water around will actually affect where these objects in the pool go. It could be something as small as a gust of air.
But if the tennis shoes came from far away, they floated in currents that were already moving.
Yes, but major currents have lots of eddies, filaments, swirls, and even jets that interact with and move objects.
What are eddies and filaments?
Eddies are formed when a current doubles back to form a small whirl, and filaments are meanders that come off from the current.
So maybe the eddies or filaments brought the tennis shoes into the shore.
That's possible because shoes caught in these small currents could travel across these major currents.
Does the Gulf Stream have any eddies or filaments?
Yes, lots of them. There are even large circulation eddies that break off from the Gulf Stream.
I think that's the answer to our oil glob mystery. The loop current in the Gulf of Mexico. Now for the shoe mystery. Do coastal currents complete the process of bringing the shoes on shore?
Yes, they can, but most of the shoes would not make it.
If they float, won't they eventually end up on shore?
No, most will end up in the Sargasso Sea.
That's the place in the Atlantic Ocean with a lot of seaweed. Why there?
Large circulation gyres in the North Atlantic Ocean move in circular clockwise pattern. Floating objects within these waters tend to move towards the center of rotation.
I guess if the coastal currents could bring the shoes on shore, now all you have to do is find out where the container fell off the ship.
Sounds like a good idea.
And if the location's right, we will then know if it's possible that the currents, dispersions, and coastal currents brought them on shore. Thanks, Dr. Moisen.
You're welcome. Glad I could help. Keep me posted.
Dr. D, we think we're close to solving the mystery.
That's great. What's the solution?
KSNN reported that the oil came from the Gulf of Mexico.
It was natural seepage. But we talked to Dr. Moisen and did some research and found out that the loop current, then the Florida current, and finally the Gulf Stream might have brought it up to the East Coast.
But we're still investigating the shoes. I sent an email to the Very Good Shoe Company, and they said that 26 months ago a container filled with their shoes fell overboard off the coast of North Africa.
We learned that on the eastern edge of the North Atlantic Ocean, by North Africa, the current flows south. Then the current flows west across the Atlantic before turning north into the Gulf Stream.
We learned at Water Country USA that the Gulf Stream moves pretty fast.
So we think that the shoes are probably the same ones that fell overboard off the coast of North Africa. But a little over 2 years seems like a long time to get to Virginia.
I know. I'll call Dr. Adamek. I'm sure he can help.
Good idea. If he confirms that it could take 26 months, then maybe the shoes and oil just happened to meet right here in Florida, where I was.
Then the shoes and the oil floated up the coast of Virginia?
That's our hypothesis.
Hi, Dr. Adamek. We have another question. How long does it take a floating object, like a shoe, to be carried by the currents from the coast of North Africa to Virginia?
Well, it's impossible to give you an exact time, but given average currents, the winds, and the recent storm tracks, I would estimate about 2 years.
Thanks, Dr. Adamek. I think our case is solved.
You're welcome. I'm glad I could help.
I have an idea. Maybe these numbers on the shoe label can be used to track the shoes. Let's email the Very Good Shoe Company. And let's see if they can confirm that these are the shoes that were on the lost shipment.
Good idea, RJ. Doesn't hurt to continue to test your hypothesis, just to make sure.
I wonder what happened to those rubber duckies that I'm Listening said fell overboard off the coast of Virginia.
Well, maybe some NASA SCI Files Kids Club members in North Africa will find them some years in the future.
Wouldn't that be interesting?
Tony, have you given up your search for sunken treasure?
I'm glad you asked. Actually, I'm looking for someone financially gifted, like yourself, to help fund my project.
Well, I can't commit financially, but if you need a diving partner...
Right. Remember the buddy system, critical for diving. And it also helps you avoid the grumpy treehouse detective syndrome.
Grumpy? Me? I'm not grumpy. I'm the perfect picture of composure. I mean, stock market, fluctuations have you going once in a while, but